Alright guys, so blockchain. What is it and why is it so critically important to know about it and to understand it and what it's going to do in the future? Before we get into the video, I do want to apologize to everyone for not having put out a video in 2 weeks. Things are picking up. We are going to have an early spring, and that is kind of crunching everything down together and making it a little difficult to find the time to put out videos. So we got to get ready for spring, we got to get ready for gardening, we got to get ready for the honeybees, we got to get ready for all the things that I do, and it's kind of crunching down on the time that I have available to make videos. But I'm making these videos literally 5 to 10 minutes a day, putting them together, and then when they're finished, getting them out to you guys. So I do apologize for the time, but let's get started. What exactly is blockchain? Most people, when you talk about blockchain, they automatically think about Bitcoin. But in 1989, the concept of blockchain came into being. Over in Bell Labs, there was this idea that in the future, everything is going to become digitalized. Whether it's pictures taken from your camera or a file that you put on, say, Microsoft Word, or a game, or this, that, or the other. Everything will eventually become digitalized. Now, in 1989, most things were not digitalized. In fact, we were in a time of the internet, basically internet 1.0 or web 1.0, where it was read-only. So you'd go on to the websites and you'd be able to look around and just read whatever somebody put on a server. You couldn't interact with it, you couldn't thumb up, you couldn't input anything into the page, you could only read. So it was a read-only web at the time, or a read-only internet. But Bell Labs was looking at the situation that more and more things would become digitalized, such as the information for Walmart was now digitalized. It was put onto the internet. It was read-only, but it was digitalized. It was put onto the internet. It was in a digital format. And they realized that as time moved forward, that more and more things, and eventually all things, will be or will become digitalized. The other thing that they were looking at is that things were the possibility of centralization was taking place during this time. And this was the time when we were in Web 1.0, but we were beginning the processes of transitioning to Web 2.0, which was read and write, or the ability to not only read or watch something on the internet, but to interact with it, to give it a thumbs up, a heart, a like, or whatever, and or a comment or a chat, or all these different things were beginning to build up in Web 2.0. And so they realized that there was this thing of centralization that was taking place, in which power was being moved to a select few, and that control of technology was had the ability to control nations and all sorts of other different things. Centralization was going to become a major problem and a major issue. Anytime you have centralization of anything, you end up with a single point of failure. So, for example, let's just say you create a web server to create a website, and you put that web servers over on Amazon, right? And let's say that something goes on. There's an explosion in the Amazon server warehouse where all the servers are located and all the UPSs, that is the uninterruptible power supplies. But something happens over there. There's an explosion, and all those systems are eliminated. Now what? Now all the transactions, all of the movement of product, all of everything that was coming to you and to other people, nobody knows where it's at, nobody knows how much money is involved, nobody knows what the loss is. Everything's lost because it's centralized in one location. So you had this concept of everything becoming digitalized and this concept of centralization taking place. And we needed a way to figure out, how do we decentralize all this? How do we decouple it from centralization and fingerprint each and every single digital file, document, record, whatever it is? And how do we determine when was that digital document created, when was it changed, how was it changed, and then make all of this open and available and transparent so that all people anywhere on earth can get in there and look at it and say, okay, this change was made here by this address or this individual, what have you. And you'll be able to see transparently everything that goes on with all of these digital assets. And many people say, well, what are digital assets? Well, your driver's license is a digital asset. Okay, your marriage license is a digital asset. You have digital assets left and right. You just don't know it. You don't understand it. You don't comprehend it. Or some people do. But for the vast majority of people out there at this point, they don't realize that most everything they have is in fact already a digital asset, including your identity. It's already digitalized. The Federal Reserve knows everything about you. The federal government knows everything about you. It's already digitized. But these people at Bell Labs were ahead of the curve. This is before everything became digitalized. This is before we had mass centralization and technological companies controlling and manipulating all sorts of different things, from votes to news to whatever they want to control and manipulate, including governments themselves. Secondly, the problem with centralization is that as long as you have a centralization taking place, all that the Revelation 2939 people have to do is come in and manipulate, blackmail, or buy off that centralized organization, and then from there they have control over every detail of that centralized organization. So if they come into your government and they seize control of that centralized spot, then they can control everything about your government. Or if they come into your bank, they can control everything about your bank. Or if they come into any given centralization, they can absolutely control it. So it's a major issue, and it's what's enabling severe wickedness and control on this earth right now. And the problem is, the issue is, how do you deal with all this, and how do you decouple this from that centralization and have proof of digital assets? And so really, as we'll make further videos discussing Web 1.0, Web 2.0, Web 3.0, and all these things, but for now, just a basic concept is that in Web 3.0 you're going to have read, write, and also ownership, and to a pretty good degree decentralization. Not 100%, because you can never truly go 100% decentralized. That's almost it's nearly impossible. But we can get it, like 85-90% decentralized, and have certain things that need to be decentralized, that should be centralized, but only those things, and we'll discuss more of this as we move forward. So we're talking specifically about blockchain, and blockchain 0.0 was created in 1989, and basically it was Stuart Haber, I apologize if I say their names wrong, and W. Scott Stornetta, and these two individuals came together in Bell Labs and began the process of figuring out how do we create an ownership of digital files, and how do we do this in such a way that it is not centralized. Now, before we get into the detail of that, and I know a lot of people are not going to want to get the details. I'm a nerd, okay? I love to dig into technology. I love to understand the underlying concepts of it and to dig deep into it and to fully comprehend it. That's just me. I'm a Virgo, just the way I am. It's the way the Lord our God made me, right? I just got to know absolutely every detail of a thing. And I'm not satisfied until I fully comprehend, understand that particular thing. So there's going to be some nerdy aspects to this video, but I'm going to try to keep these videos as short as possible because most people just don't have the time for long videos. But let's take the concept of what's happening here. So right now, the way things operate on our earth is simple, right? What we do is we as a people, when we need to do something, we go to a centralized power or a centralized entity that we trust in order to do some kind of transaction or some kind of movement of value. So taking an example, financially speaking, we'll use the example of a bank. So what happens is you have person A over here that wants to move money to person B. Now person B may be in the same town, maybe in the same state, or maybe that individual is clear across the earth in a whole other different nation, right? We don't know where the two are, but to do the transaction, they're going to go through this central entity, this third party that they both trust in order to do that transaction or that movement of value. They're going to go through the bank So party A is going to move $10 to party B, and party A is going to move that to the bank, and then the bank is going to move it to another bank, and then to another bank, and then to another bank, and to another bank, until eventually party B receives the transaction. Now, again, you have centralization. So what happens if a hacker interrupts that process between bank, as it's moving from bank to bank to bank? What happens if a hacker comes in and interrupts that transaction? Then all money is lost, and an investigation has to get started, and the money never made it to the individual. Okay, that's just one issue. There's another issue that about 40% of the population of the entire Earth is unbanked, meaning they have no capability, no ability to actually access a bank or to participate in banking. And so if they want to move funds from place to place, they have no ability to do so. Okay, now blockchain is going to interrupt that and disrupt that and make that possible for every single living soul on this earth, no matter where you are. Okay, again, blockchain is critically important, and it is going to change the future in ways untold at this point. We are in the embryo stage of blockchain. So right now we have to go to a trusted third party. What blockchain does is it literally eliminates all third parties. Okay, so that means it eliminates the banking system. That means it eliminates the DMV, right? The Department of Motor Vehicles, all this stuff. It eliminates the courthouse for say marriage licenses. It eliminates the government, because you can put government into the blockchain and control it that way. For example, government is literally a third party, right? We, the people, all over the earth in all sorts of nations, create government to uphold our rights and our liberties and all these things, and to create justices and all this stuff. Well, all of this can be done through digital contracts, and have no need for that third party, nor the need of cost of that third party, because the blockchain has a minute cost compared to the cost of an actual third party. So blockchain was actually, the concept of blockchain came into being in 1989, and there is a white paper. Matter of fact, let's go take a look at that, and I will leave the link to this in the description of the video. But how to timestamp a digital document by Stuart Haber and W. Scott Starnetta, or Starnetta. I'm not sure exactly how you say the names, and I apologize if I got them wrong. But basically what this document does, it's a white paper, and anytime you're doing research into any given blockchain ecosystem, you need to look at the white paper. But what this entire white paper is explaining is the trusted timestamp service, and this blockchain that was basically brought forth in 1990, the next year, is still in existence to this very day, and the information from that blockchain is posted in, I think it's the Washington Post, I'm not sure, it's in one of the major newspapers. Every so many weeks, or 1 week, or every month, or whatever it is, they post it into the paper so that people can have reference to it. It still exists to this very day. But again, the issue that they were looking at is digital assets, right, or digital files, which can come in any format, right? It could be a picture, it could be a movie, it could be a video, it could be just a written document, it could be any number of different things. It could be a marriage certificate, a driver's license, it could be any number of different things, any digital file format, any kind of digital file. And every single digital file that has ever been created has this fingerprint about it, right? So you have a document, and what's contained in that document creates a fingerprint. And so each document that is put into the blockchain has a fingerprint. It gives absolutely no information concerning what is in that file. It simply gives you the fingerprint of that file. If you change any given thing in that file, the fingerprint of that file changes. And so if somebody comes in and tries to manipulate that file and tries to post that to the blockchain will see that the fingerprint has changed, and it will log what address did that, and when they did that, why they did that. All that stuff will be right there on the blockchain, open and transparent. Anybody can see what happened and determine if it was legit, unlegit, and go from there. But as long as it's the same file, even if you have 10, 15, 20 duplicates of it, it's all going to have the exact same fingerprint because it's the same file. But you change any given character or any image or anything on that document, the fingerprint of that document changes. So each digital document has a fingerprint, and it is a unique fingerprint. But again, when it's a unique identifier of the document, but it doesn't expose or reveal to you what is contained in that digital file or that digital document in any way, form, or fashion. For example, if we take a human being, right, and we take an individual, and we can identify that individual by their fingerprint, but that fingerprint doesn't tell us what color that individual is. It doesn't tell us how big the ear is, or what the slant of the eyes are on that individual, or what the individual is wearing, or any other thing about the individual. It's simply an identifier of a unique identifier of a single individual. That's what the fingerprint of the digital file is. It is a fingerprint of uniquely identifying a document. That's all that it is. It does not expose or reveal anything that is contained in that document. And so what this company, what this white paper is talking about, this fingerprint, is called a hash. So what I've done is I brought you over here to qvault.io, right? And I want to show you how this hash system works. So this is the SHA-256, right? This is a hash system. So if you have a document and the only thing that document contains is absolutely nothing, and you hit hash me, there's the hash for that document because it says text to hash, right? So if we just put in an A and we hash me, this is the hash for the letter A, right? So what I want to do is I want to copy and paste that. Right, we'll copy it. And we're going to bring up the just notepad, and we're going to paste it on here. Okay, so here's the hash, right? Now let's minimize that, and let's put in the value B, and we'll hash that, and we see this is the value for B, right? And let's just put Bob, right? And then we'll hash it. So if the document contained the word Bob and that's all it contained, this would be the hash for that document, right? But this hash may reference not just the word Bob, but it may reference other words. So even though we have this hash for the word Bob, and this hash will produce the word Bob every single time, or Bob will produce this hash every single time, this hash may also represent other things. And so you cannot guess that this hash means Bob. It may mean this, it may mean that, it may mean other things, right? And it doesn't matter if you just put in a lot of stuff like the dog walked down the street, and then we hash that, and then we see it's a whole nother hash, right? But the same hash will always come from the same word. So if we go back to A and hit hash me, there's the hash, and we bring up notepad, and let's just pull that up a little bit here. We can see that it's exactly the same hash, right? It's going to come out the same every single time. So depending on what the digital document contains, a hash is created for that document. Whatever that document did or has contained in it, whether it's a picture, a document, words, or whatever it is, a audio file, video file, whatever it is going to produce a different hash according to what is contained in that document. That is the quote-unquote fingerprint of a digital file. Okay, and so these hashes are going to become important. Now what this document lays out is how you create a decentralized, transparent, immutable database. And not just a database, because we have databases already. We've had databases for years. The problem with the databases that we have today is that they are centralized databases, and they are single points of failure. This is where hackers can come in and hack the system and create a failure in that system, or we can have wicked entities come in and blackmail or manipulate or buy off that centralized power and control that power. We have all these issues because things are completely and utterly decentralized. If that centralized location loses power, plus this uninterruptible power supply, then we have a loss of record. We have all of these issues surrounding this centralization issue that we have had basically for 6,000 years on this earth. And that really is what has allowed the wicked to do wickedly on this earth, is that they have been able to centralize things and control that centralization. And so this document is showing us how to create a decentralized, distributed ledger of transactions, or whatever it is, digital files, whatever it is, that's going to be a distributed ledger, not just a centralized ledger. So what this document laid out, and basically this is blockchain 0.0, right? This is the birth of blockchain, and this blockchain still exists to this day. But what it's basically laying out is you take a file and you get the digital fingerprint of that file. And then other files, another transaction takes place, or another whatever takes place on the blockchain, and that digital file receives a fingerprint. And then another digital file comes in and it receives its fingerprint, its hash, okay? And you get all these different transactions, or all these inputs come in, and you take all these inputs, and all of that goes into a single block. Now, a block can contain one transaction, it can contain 10,000 transactions to infinity, right? It's all dependent on the whoever developed the blockchain as to how many transactions or inputs go into a single block. But you take all these files and they go into a single block, and then that block gets its own fingerprint, or what we call hashtag today. A hash, right? An encryption that takes place that makes it unique. And then that block, then after that block is complete, the next set of transactions, or the next set of inputs that come in, those inputs go into a new block as that block builds out until it reaches its maximum amount of transactions or inputs, and then that block is complete. And then that block is added to the last block, and then a new block is created, and then all the inputs are put into that block until that block is complete, and then it's added to the chain of blocks. And so this is where you get the word blockchain. Now, what makes this interesting and powerful is that what you have in any given block is that you're going to have several different parts to it. So remember that the block itself contains many thousands of transactions, or 2 or 3 transactions, or whatever that block size is, how many inputs it can put into it. But it has a block number. Let's say we're at block 0, the very first block, or the genesis block, or the very first get-go. That block is going to be called block 1, or given a name, block 1. It's going to have a timestamp when that block was completed. It's going to have a header hash that's going to tell us the hash of this block, this unique fingerprint, right? And this unique fingerprint in a genesis block is going to be 000000000, because it's the first block. It is the genesis of the entire blockchain, right? Then you have underneath that, you're going to have a hash of the previous block header, and in this case there is no previous block header because it is the genesis block. It is the 0000000, 64-bit, 64 numbers of just zeros, 64 digits of zeros. So it's not going to have a previous block header, and then it's going to have this thing called a nonce. And this nonce is very important, and this is what the proof of work, the miners out there are trying to determine, is what is that nonce. And then you have the block data, right? All of the transactions, all of the different inputs that went into that block. Now when that block completes, it becomes the first block. Next block is being developed as all the inputs come in, or all the transactions come in. And again, we have block number 2. We have the timestamp of this block. We have the header hash of this block. Again, it's the fingerprint based on all of the information contained in that block. It has a unique hash number. And then below that, we have the hash of the previous block, which in this case would be 0000000, because it's directly tied to block 1. And then you have the nonce for that block, and then you have again the data that's contained in that block. And this continues on. So after that block is complete and the next block begins the process of being built, you get all of these numbers, all these inputs and transactions come in. And once that block is complete, it goes out to the miners. The miners determine if it's all legit. If it is legit, whatever miner figures out all the information and figures out the nonce and all that stuff, they get a coin or something in return for the work that they've done. and they add it to the block. And so you have this block now is going to be tied to block number 2 under the hash of the previous block right here. So it's every block is tied to the block prior. And as these blocks develop and you get 20, 30, 40, 50 blocks, it becomes harder and harder and harder to hack this system, because each block is tied to the last block. So if you go in and you try to change block number 2 or block number 1, right, and you're at 10 blocks into this, then every block after the block that you try to change is going to be wrong. And so it's going to be rejected by the blockchain. In other words, it's immutable. It cannot be changed. The only way that you can change any given block is to take the block that is being built now and say, I want to make this change in the block information, and then it's added to the new block. And now we can have an open record, open source record of what change was made and why it was made and all these kinds of different things. And why would you ever want to change a block? Well, if you're a hacker, you're going to want to try to change the blocks in order to control the blockchain, right? But as the blockchain develops and grows and becomes exponentially bigger, it becomes impossible to do so. So the other part of the blockchain is that it is a distributed network. It's a distributed blockchain. It is a distributed ledger. So in other words, this is not centralized onto one server or one computer or one company, but rather it is distributed across all of the users of that blockchain. So everyone that has, for example, a wallet on any given blockchain, say we're talking about Bitcoin, which is its own blockchain, right, separate from the other coins. But let's say we're talking about blockchain. You create a actual wallet for the blockchain, then you download the entire blockchain to your computer, and what's happening is that every time a block is added, your computer is updated with that block information. And so your computer has the blockchain, your neighbor's computer has the blockchain, a person clear across the earth has that blockchain, and clear across the earth from there they have a blockchain, they have it on their computer, and you have tens of thousands of computers that all have a copy of the blockchain and is being updated as the blocks are added to the blockchain. So in order to change the blockchain, you have to seize control of over 50% of all of the computers that have that blockchain information on them, that database on them, in order to manipulate it. In other words, it is basically impossible it's immutable. It's impossible to change the blockchain. Once it is recorded, it is permanently recorded, and it is distributed. It is not controlled by any individual, not controlled by any entity, and there is no need for a third party in any way, form, or fashion. This is the absolute basics of blockchain. I will make more videos that go into more geeky detail concerning blockchain. Let's take an example. No, let's not do that in this video because we want to keep these as short as we can. But the basic concept is that when you create a blockchain, now all of these, like for example, let's say we create a banking blockchain, just specifically banking, right? Rather than a central bank controlling that blockchain, you have a blockchain that is distributed across tens of thousands, if not millions, or hundreds of thousands of computers all over the earth. And all the different banks can then go into that blockchain, get the information it needs, use the blockchain, and then update the blockchain with the next block. And so rather than having this competition between all of the banks, now all of a sudden you have a cooperation going on between all the banks. They're all accessing the same exact distributed, not centralized, distributed blockchain. And so now they all can gather the same information. Everyone has access to the same information. You don't have Facebook or Google or any of these companies controlling that information. Instead, it's in all of these computers and open and available to all people. And anyone that needs to access that can access it and use that information and update the blockchain as new transactions are brought forth. And the question is, the other part of the question of, why would you want to change a previous block is, maybe you're not a hacker, maybe you're a legit person, but say you have, let's use Bitcoin for an example, okay? It's just for an example. There's tons of blockchains out there, not just Bitcoin. We'll get into more detail that in the next video, because right now we have blockchain 0.0, which is the one we're talking about, then blockchain 1.0, and we move forward. Blockchain 1.0 being Bitcoin. But anyway, if we take Bitcoin, let's say that you have one Bitcoin, right? And you want to take half of that Bitcoin and you want to move half that Bitcoin to your your sister or your brother, right? So what you would do is you would create a transaction peer-to-peer between you and your brother, skipping the third party, trustless, because it's all in the code. It's immutable. It cannot be changed or manipulated. You know the outcome, and there's no trust needed. You don't need to go to the bank. You just go person to person. It's trustless because even if you don't know the person, it doesn't matter. Whether or not they have the funds is determined by the blockchain. And if they do have the funds and y'all execute on it, that money is moved, irregardless, because it's immutable. It's going to happen the same way every single time, no matter what. You don't have to trust it. You just use it, and it works every single time, no matter what. But you want to move half of your Bitcoin to your brother or sister, right? Well, on the blockchain, in all the previous blocks, you're showing one Bitcoin. But now you want to move half of your Bitcoin to your brother and sister. So you want to take 0.5 of your 1 Bitcoin and move it to your brother or sister. So you do this transaction, and this transaction is in the new block. Okay? And in this new block, you are changing the previous block that said you had 1.0, because in this new block, on this new ledger, it says that you're taking your one Bitcoin, and you are taking half of that, 0.5 of it, and you are moving it to party B, right? And now you have moved 0.5 Bitcoin to party B, and so now the blockchain needs to update, showing that you no longer have 1 Bitcoin, you have 0.5 Bitcoin, and party B has 0.5 Bitcoin. So now you've updated the previous blocks that you no longer have 1 Bitcoin, you now have 0.5 Bitcoin. Or if someone gave you 0.5, now you have 1.5 Bitcoin. Right? So we'll talk more about that in the next video as we go into blockchain 2.0. I want you to understand the basic concept here is that we are talking about digital assets and decentralization and the removal of control of third parties and the elimination of third parties. That's why governments oppose it. This is why we're dealing, like for the example, the America Competes Act that went through Congress, and they're trying to shut down and control who can move digital assets and who, this Americans. You're going to have these issues keep coming up because in the long run of things, it eliminates the need for government. It eliminates the need for banking. It eliminates the need for DMV. It eliminates the need for a courthouse. It eliminates the need for a courtroom. It eliminates all these third parties completely and utterly. And so these controllers and manipulators, what I call Revelation 2939 people, they are going to oppose this. The problem is that they cannot control it because it is distributed. They can take out 50 computers and it's still on 6.2 million other computers. And when those 20 million, those 10 million, or 10,000 computers or 20 computers that they shut down, when they come back online and they connect back into the blockchain, all those other computers that were still running are going to update their blockchain and bring it up to speed to where the blockchain is currently, and everything just continues on. And so let's say all of China, right? China shuts down Bitcoin mining, and so all those Bitcoin miners that have the blockchain there, they're shut down. But if they ever come back up online, it doesn't matter that China shut it down because the United States has people in it, Europe has people doing mining, all these people all over the earth are doing it. And so if people later down the road, China says, okay, let's allow Bitcoin mining again, they'll start up their computers and they'll go check with the ones in America or Africa or Europe or Russia or wherever, Canada, Australia, wherever, and pick up that database and update it and then continue on. You can't shut it down. They cannot shut this thing down. Blockchain is just, there's no central point that they can just come in and say we're shutting you down. They can't do it. So you're going to have a fight that it's going to take we the people all over the earth, not in America, every nation on earth, all people all over the earth coming together to oppose these controllers and say it doesn't, you need to do this, you need to do that. You're not going to control who can be a DEX and who can't be a DEX and who's going to do this and who's going to do that. So you're in a battle, right? And again, you are in the embryonic stage of Web 3.0, blockchain, and cryptocurrency. My main focus right now is to help you guys to understand blockchain itself and the power of it and why it is so critically important. And that you have a battle that you are involved in, whether you know it or not. Blockchain is the future. Okay, but we have hurdles that we're going to have to get through, like this America Compete Act, for an example. Okay, and there's other things that were happening in the past that have been overcome already, but there's going to be new things come up all the time. I mean, we see where we have Arizona trying to pass a bill to make Bitcoin legal tender. We see where Russia is over here saying, look, we're going to allow Bitcoin, but we're going to put some regulations on it. And, you know, we see the acceptance of Bitcoin coming all over the place, all over the various different nations and all the different states of various nations, and so forth and so on. It's coming. But there's going to be this battling that's going to be taking place in the process. So in the next video, we're going to move into blockchain 1.0. Okay, this is blockchain 0.0. I will leave a link to this paper, this white paper, if you want to come and read it. It just basically shows you how blockchain came into existence, and this blockchain that they created from this white paper still exists to this day. But the basic concept of blockchain is that it's going to take digital assets and create ownership and have that logged on a blockchain that is immutable, unchangeable, unmanipulatable, unhackable, uncontrollable, etc. At the same time, it's creating decentralization. It's moving away from centralization and control, manipulation, and points of failure, and distributing it across hundreds of thousands and millions of computers all over the earth, to where no matter what happens, unless the power all over the earth in every given point on the earth, it ceases to exist. And if that's the case, we're going into a dark age anyway. It doesn't matter about digital assets, and it doesn't even matter about governments. It doesn't matter about anything at that point, to be honest with you. If we get to a point where we lose power across the entirety of the earth, we have a major issue, and we're going into a stone age, right? So it wouldn't matter. But you know, if any given nation or multitude of nations all lost power all at once, say we're in a real war and 5, 7, 8, 9, 10, 15 nations all lose power, right, during this battle where bombs are being dropped and all that stuff, but yet 2 or 3 or 4 or 5 or even just one computer remains running anywhere on this earth, that blockchain will continue no matter what. And then when other computers come online, they will go to that one computer that's still running the blockchain, update itself on where the blockchain is at, and it will just go right back. We saw this, for example, when China shut down the blockchain, the BTC or Bitcoin mining. When they shut down the mining, we saw this sudden drastic drop in hash rate, which is, you know, they're running the hashes, they're doing the proof of work, and that hash rate dropped, but it didn't shut down Bitcoin, because there's Bitcoin miners all over the earth in all sorts of nations, and so it had an effect on the chain, but it did not shut down the chain, because you cannot shut down the chain as long as one computer remains. All the other computers, when they come back online, can reconnect and update their databases, and it just continues and continues and continues forever. So basically, what blockchain is basically cloud computing on an earth-wide scale, and it's uncontrollable, unchangeable, which is immutable, right? And it's bringing about the third phase of the internet, Web 3.0, which is ownership, where you own your comment, or you own that like, that thumbs up that you gave, or you own that chat that you just did, or you own that video. Not YouTube, you own it, right? As you guys know, I back up all of my videos onto the blockchain. I use Library, which is now called Odyssey, right? That is a blockchain version of YouTube, and that is the future. You know, I made a whole video about that a year ago, or maybe it was a year and a half ago, but a while back, that this is the future, because blockchain is in fact the future, and it is going to change the world in ways that we can't even begin to comprehend yet. And it's going to make wickedness more and more difficult. But as the technology develops, and as we come out of this embryonic stage, we're going to see the development and growth of blockchain, and we're already seeing companies all over the world beginning to adapt and use blockchain. The United States Post Office has a patent for blockchaining the post offices, which, you know, in reality, if you want to know what happened with the election and the mail-in ballots, all you got to do is go to the U.S. Post Office's blockchain and determine how many of those votes were not on the blockchain. If they're not on the blockchain, they're not legit, because the United States Post Office has a blockchain. So, at any given point in time, if they want this movie, quote unquote movie, to end, all they got to do is bring out the blockchain from the United States Post Office and show all of the illegitimate votes and end it and put Mr. Trump back in office if that's what they want to do in the movie. But the whole point of the movie is to bring everyone to a point of precipice so that they are willing to change themselves and to come out of the lies and deceptions and to move into this new world of opportunity, of prosperity, of cooperation rather than corporations, and everyone working together and having this distributed ledger or decentralized databases all over the earth for all sorts of different things, whether it's medical records, vehicle records, houses, land ownership, whatever. You'll see all of these things come together over the next 10 years. And you are at the groundbreaking point of this. You are at the embryonic stage. Yes, it was 1989 when this document and blockchain 2.0 came out. We'll move into BTC in the next video, guys. Let's go ahead and kill the video here so they don't get too long. God bless every single one of you. Father bless you, be with you, prosper you, and help you, and open up your mind to the truth, and to lead you and to guide you. And we'll catch you guys in the next video.